Hello, and welcome back. I'm Daniel, and here in this video, we're going to put another solid brick into our functional programming fundamentals. We're going to talk about higher order functions and curried functions. We touched upon these concepts very briefly in the last videos, but here we'll discuss them in depth. Alright, so in our development environment, let's just create a new Scala application in the Part 3 functional programming package, and let's call this Hofs and Curries. Of course, make this an object and hit OK and extends app. Alright, so in the last videos you saw function types. My question for you is, what keeps us from defining a super function with a type, and I'm not going to have any limits here. Let's say I have this super complex function type like int, arrow, parenthesis string, comma, int, arrow boolean, arrow int here, which at the end has an arrow, and the return type is int, arrow int. So what keeps us from defining such a function? Well, nothing. But how do you read this kind of function? Now try to pause the video for 1 second and try to read this function type. So what kind of parameters does this function have, and what is the return type of this function? So first let's look at the return type of this super function. The return type is at the right hand side of this arrow here. So the return type of this super function is another function which takes an int and returns an int. Now the parameters here are, one is an int, and the second is this whole guy over here. And this guy is another function which takes an int and the function int to boolean, and the return type is int. So the super function takes two parameters, an int and a function, and returns another function. Now, as we touched upon in the last videos, such a function that either takes function as parameters or returns functions as result is called a higher order function, or affectionately a Hof. Examples of higher order functions that we've already written are map, flat map, and filter that we wrote in my list. So all of these are higher order functions because each of them have a function as a parameter. Now, as you might expect, higher order functions are all the rage, and functional programmers are in love, they're head over heels about higher order functions. And we'll start to think in terms of higher order functions throughout the rest of the course. Now let's see an example. Let's say we have, we want to define a function that applies a function, another function, n times over a given value. So this special function, let's call this n times, will take three parameters: the function f, the number n, and the value x. F is a function that will be applied and is the number of applications of this function, and x is the subject of the applications of this function. So if I call n times, for example, with any function f, and say the value 3 and any value x, then this will be 3 times the applications of f over x. So that will be f applied to x, but 3 times. So f applied to this guy, and then another f applied to this guy. So f applied to f applied to f of x. So this is a classical example of a higher order function. It takes a function as a parameter and just applies it a number of times. So let's think about how we would implement this. So let's define the method n times, and this will take a function f. Let's say the function is int to int for simplicity. And n is a number, and x is a value. And the final return type is going to be an int. So let's think about this. What if n is less than or equal to 0? Then in that case, there is no applications of f to consider. So if n is less than or equal to 0, then I'm just going to return the plain value because I'm not going to apply f to it. All right? Otherwise, and let's think about this. So I put in an example here with n times with f, 3, and x, which applies the f 3 times over the value x. But what is, for example, this guy right over here? So f applied to f is basically n times with the same function f, but 2, and the value inside, instead of x, is f of x. Think about this. So n times of f2 and f of x applies f 2 times, and inside, the value here is f of x. So this is very mathematically tricky. So in general, n times with a function f, a number n, and a value x is f applied to n times over the value x, which is the same call n times with the same function, but n minus 1 times, and the value inside will be f of x. So this is the recursion that we are going to apply here. Think about this and look at the example to see how it makes sense. All right, so the implementation is going to be n times with the same function f, n minus 1, and the value here is going to be f applied to x. And here we are, some good programming students, seeing functional programming suddenly turning into abstract math, and that's because it is. Functional programming is a direct mapping over a number of branches of mathematics. Now, let's define a little function that just increments a value by 1, and let's call n times on that function. So let's call this plus 1, which takes an int and returns that int plus 1. So this is a basic incrementer function. And let's try to see what happens if I call n times with this plus 1 function. And let's call this 10 times over the value 1. What do you think this is going to happen? Well, we'll call plus 1 on the value 1 10 times. So basically we'll increment 1 10 times. So we should expect to see the value 11 printed to the console. So let's compile our code. And we get not implemented error. Oh, of course, because we've put in the question here. Let's replace this with a null or something like that, because we're not actually using this super function. So let's right click and run. This time we'll compile faster. And yes, we see the value 11 in the console. All right, so this example was pretty simple, although if you ask me, it's quite a convoluted way of incrementing a value 10 times, but it serves as an example of how you can use higher order functions to compute something. And as you'll get to more complex APIs in your programs, you'll start to need this kind of stuff. Now, speaking of APIs, there is a better way to implement this n times function. And the option is to, instead of passing all parameters at once, like f and n and the value x, we can simply say that the function n times takes a function and takes a number and returns another function, which is basically the application of this function n times that you can then use on any value you want. So here's what I mean. So I have a function called, let's say, Ntimes Better. And this takes the function f as a parameter and the number n as a parameter, but instead of taking the value x as a parameter as well, we can save that for later and say that this guy returns a function from int to int. Now, the difference here is that in the n times better case, instead of applying f n times to the value x, we save that for later, in the sense that if I say n times better with f and n is basically x arrow f of n times with x. So instead of actually applying f n times to x, I return a lambda that you can then use later however many times you want and apply it to various values. So if I have, let's say, increment 10, which is n times better of this increment plus 1 that we called n10, this will return basically a lambda that applies plus 1 10 times to x. So you can then use later and say val y equals increment 10 of 1. So you can use increment 10 as if it were a function that you computed earlier by calling Ntimes Better with +1 and 10. Now, this is a subtle distinction, and it might not make too much sense, or it might not be too intuitive at this point, and that is because you haven't gotten into the problems that require you to think in terms of higher order functions in this fashion. But trust me, this style of thinking will come natural to you as you write more Scala code. You might be wondering, why the hell do I want all this higher order function stuff just to increment a value 10 times? This seems overkill. Don't worry too much. This style of thinking will come natural to you. It will just take some time and practice. All right. So this is what we're doing in this course. So let's get back to the implementation. The logic is going to be fairly similar. So if n is less than or equal to 0, then instead of x, I just return the identity function, which is a lambda, which takes an int and returns that value. Otherwise, it will return a lambda. Let's put in the full definition. It'll return a lambda whose implementation is going to be basically the same as this guy right over here. So Ntimes Better, but with the proper parameters in place, so f and n minus 1, applied to f of x. All right. So this syntax is a little bit tricky. So Ntimes Better, as you see from the function definition, returns a function, and that'll be applied to f of x. All right, so let's try to test it. So let's create a simple value like increment 10. Let's call this +10 to be consistent in notations. So this will be Ntimes Better with n and +1, or +1 and n, which is 10, right? And let's print +10 applied to the value 1. We should expect to see the same value 11 printed to the console. Of course, because +10 is actually Ntimes Better applied to +1 and 10, which is a function that applies +1 10 times to whatever value we pass in here, in this case 1. All right, so this is not really easy to think about. If this was too hard or too abstract for you, feel free to rewind this video or try to run these functions by yourself. Functional programming is not easy. Whoever tells you otherwise is either a master of functional programming, or they're lying, or they have no idea what the hell they're talking about. So take some time to get these concepts right. If you get them right, you're ahead of 99% of Scala programmers who basically write imperative code with Scala syntax. So we've gone quite a long way from dealing with expressions and while loops and actually dealing with abstract higher order functions. I'm really proud of you. All right, now let's move. If you've noticed, this style of writing, we encountered that in the previous videos as well, and we talked about a new concept which we didn't really get into depth, and it's called curried functions. So we wrote that little super adder function, which I'm going to write here again, which is xint arrow yint arrow x plus y, and with the proper spacing here in place. Now, what is the type of super adder? Well, it's int arrow int arrow int, with the note that the arrow sign here is right associative. So this function receives an int and returns another function. So basically, our type for super adder is actually this guy, with parentheses implied by the compiler. So we can then call super adder by creating some additional helper functions. If I say add 3, this is super adder with parameter 3, and this is actually a lambda from y to 3 plus y. All right, so we can actually print line, for example, add 3 called with 10, and this will print 13 to the console. So these curried functions are very useful if you want to define helper functions that you want to use later on various values. Now you see that if you actually want to call super adder with all the parameter lists, like super adder with 3 and 10, you can actually do that. So supply 2 parameter lists. Now Scala supports almost another kind of curried functions by specifying functions with multiple parameter lists. And the way that we do that is, for example, if I want to write a curried formatter which wants to turn a double into a string according to some kind of format, I would write something like curried formatter, and I would receive a format and a double, let's say x, just like that, with 2 parameter lists, and return a string as a result. And the implementation is going to be c.format x, just for a simple implementation. There is a format function in the string class, but the implementation here is beyond the point. The point is that I can define a function with multiple parameter lists to act like curried functions. So I can then later create various formatting. So if I, for example, say standard format, which is of type double to string, and the value of this is curried formatter with, say, %4.2 f, then this is a valid function. Standard format is a function from double to string that applies curried formatter with this format later to whatever value I pass to it. I can create as many formats as I want. Let's say I create the valid precise format, which is also a function from double to string. And the value of this is going to be curried formatter, and let's say I pass in some more precise format, say %10.8 f. And let's see what happens if I print line standard format with math.py and print line precise format with math.py. So notice that curried formatter acts like a curried function because I can then later create sub-functions that apply curried formatter with fewer parameter lists, and then I can then use them with whatever value I want later. All right. So if I right-click and run this, look, I see 3.14 because the curried formatter is applied with 4.2f, and the precise format applies with more decimals. Now, curried functions like these can have as many parameter lists as you want. Now, one thing to note, for functions with multiple parameter lists, if you want to define smaller functions later, you have to specify their type. Otherwise, your code will not compile. So if I right-click and run this, try to run this, the compiler will complain because it will not know what type this standard format function will have. The proper way to do that is to use partial function applications, which is an advanced subject. We're going to talk about that in the advanced course. But for now, just be sure to specify the types for your smaller functions. All right, so an important topic, let's recap. So we've learned that functional programming is all about working with functions. So we need to pass functions as parameters or return functions as results. So basically we want to work with functions as we work with any other kind of values. So this introduces the concept of higher order functions, and we've seen some examples. And then we dealt with currying, which is a byproduct of our need of dealing with higher order functions. And currying deals with functions with multiple parameter lists. And we've seen examples where a curried formatter can take multiple parameter lists. You can have as many parameter lists as you want, and you can define smaller functions to use later. All right, this is Daniel. This was a crucial topic, so make sure you get this right. Rewind this video if you need, but make sure you get this right and you'll be ahead of most Scala programmers. Now, join me for exercises in the next video where we'll get to practice higher order functions.